I'm going to spend the next 30 or 40 minutes talking about an actual customer that we've worked with. I think a lot of times when you see presentations that are given by software companies, they do a really good job of presenting their software. A lot of times it's much more focused on, um, it's not customer focused, right? So I want to show you guys an actual real customer and how they were able to utilize the 3D experience platform. And I'm just going to minimize the chat window here because it's a little bit distracting for me. If you guys have a question or something comes up, Prasad, just stop me and let me know and I'll answer. Okay, so the company that we're going to talk about is a company named Resonant. Um, and maybe I'll stop sharing my video too for a second here, just for bandwidth issues. But I'll come back on at the end so we can interact live. Read again. All right, here we go. Okay, so the company that we're going to talk about is a company called Resonant. What we're going to start with is I'm going to talk a little bit about Resonant, what their struggles were, how they were currently using simulation. I'll talk a little bit about Resonant and their adoption of the 3D experience platform, why they adopted it, what they thought was important, and then the journey of getting them onto the platform and using it. And then we'll wrap up with any Q&A or some calls to action. So Resonant is a company that started in 1989. They are based in South America. They're actually based in Peru. Their niche, their specialty is basically underground mining. So it's specifically they wanted to make compact underground mining vehicles that were affordable. So you can see now they're in over 17 countries. They make a handful of products. They're quite successful. So let's talk a little bit about a little bit more about the company. So again, they started in 1989. Their first product that they launched was this product called the Raptor. It was a real milestone for them. It was a very affordable solution for many underground mining companies, right? So that was back in 2001. They they first sold the Raptor to Zambia, so in Africa. They entered the South American market in Chile. They created what's called this bolter tool, which can actually cut through rocks and bolts, so that the small bolter 99 and the bolter 99 were really national inside of Peru, as well as international hits for them. So that they started doing these drilling rigs. They entered the Mexican market. They really started to consolidate in the African market. So, and I'm not going to talk through all of these, but Mookie was another real game changer for them because it was the smallest underground mining rig at the time. I think it actually might still be. And the Mookie actually spread to 5 different continents. So they started to get a real worldwide audience and a worldwide customer base, right? South Africa. This Scaleman is a product that we're actually going to be looking at a little bit. They actually entered the Russian market in 2018. I know Russia's a bit tricky to discuss right now, but back in 2018, it wasn't. And hopefully this video is coming through for you guys. So you can see this is that last product that we talked about, right? So you can see drilling through rock from an analysis standpoint. This is a pretty complicated problem, right? You have vibration concerns. You have significant loads, right? It's a very large load. You have vibration concerns. You have cooling concerns, right? You can see there's a whole bunch of fluid that's flowing through here in order to keep the tooltip cool. So, relatively simple kind of geometry, but a pretty complicated type of analysis, right? Based on the criteria and the needs for this specific company. So what Resonant was seeing was they were seeing a lot of field failures when they after they built their products. So you can see they had a real reliability issue. They were getting all of these cracks after utilization and after pretty low cycle utilization, right? So it wasn't like the thing had been in the field for 5 or 10 years. It started to fail pretty early on. So that was one issue that they were very concerned about, right? Those field failures. And I'll talk a little bit why they were concerned about those field failures in a couple slides. They also had a couple industry standards, and depending on the country that you're in, the industry standard could be a little bit different, right? So they had what's called falling object protection. So that's basically this is the roof of basically a vehicle. So someone is going to be sitting underneath here, and different countries have different criteria for the falling object, right? So the height that it could be falling from, as well as the amount of energy that falling object could impart on the roof, right? They also had something called rollover protection, which is basically the vehicle being hit from the side and protecting the user, right? So obviously there's going to be somebody sitting inside this canopy, and you want to make sure they're safe. So when we first started talking to Resimend, this is what they told. This was kind of their current configuration at the time they started talking to us. So they had about 20 Solidworks licenses that they were doing their CAD design with. So Resimend, really strong Solidworks customer. They had been using us since their basically their introduction. So 20 users doing CAD design. They had a couple users that were using SolidWorks simulation for just really basic structural analysis, linear dynamics, like frequency analysis. And then they had a third-party tool that they were using for complex analysis, so more advanced fatigue, multi-body dynamics. So they were either using that third-party tool or they were contracting that work out. And guys, just give me 1 second here. 1 second, I'll be right back. Okay, sorry about that. So, that was their configuration when they first came to us and wanted to talk, right? And they realized that, this step right here, having a third party or consulting that work out, was causing them a bit of delay. So they realized that was kind of a chink in their armor, right? Or like kind of a bit of a bottleneck in their design process. Now, in addition to that, they also had two different kind of product development cycles. So their one of their development cycles would be for new products, and they were doing for each of the new products that they designed. They would design it, they would simulate it, then they would manufacture, and they were seeing that they were building about 10 prototypes a year, and each prototype was taking about a month. So that was when they had new product launches, and there wasn't a lot of simulation really driving the design process, right? So everybody was kind of working in a separate bucket. So the designers would come up with the design, they would simulate it. If they saw some glaring problems, they might kick it back to the designer. But this wasn't really a really kind of seamless and bi-directional process right here, where simulation was kind of driving their design. So there were a lot of prototypes that they built that were just not good designs because they weren't doing enough simulation, and they realized that, right? They also had an aftermarket process. So they would manufacture a design, then there would be a field failure. They would do some very advanced simulation, either in-house using that third-party tool, or they would consult it out. Then they would do a redesign, and then they would manufacture the redesign. Now, here's the thing that Resimend did that I don't know a lot of other customers or companies that do this. First of all, they would send a designer out into the field to try to figure out and rectify what the problem was. But they would reimburse the company for the time that they lost revenue for not being able to use the tool, right? So they had to turn these around really quickly because Resimend was paying. So you can for a company, that there are huge costs there associated with reimbursing one of their customers for not being able to use the tool, right? So you have warranty costs, and you have to figure out exactly why that thing is failing in a very short time, right? For a product that's out in the field, it's not like this is sitting, at an airport in, San Francisco or somewhere in South Africa, in Johannesburg. This is out in the field, potentially inside a mine. So this is a pretty tricky, when there were after product failures, it's a pretty tricky thing. So that's kind of where they were. And that's, they kind of reached out to us and they were talking to us. They're, again, a really close customer of ours. They were talking to us about some of their challenges. So we decided to talk a little bit with them about the 3D Experience platform. Now, I know you guys are probably exhausted of hearing about the 3D Experience platform. I'm going to give a real brief summary about how I think about it. I'm not going to spend a lot of time here. Dassault Systems is basically a conglomeration or a group of a bunch of different brands. So everybody knows SolidWorks. That's one of the brands. CATIA is another brand. Simulia, which is the brand that's responsible for developing all of the analysis tools that Dassault Systems has, including Abacus, including SolidWorks simulation. Actually, the Abacus developers are now responsible for developing SolidWorks simulation. The 3D Experience platform basically brings together the best of all of the brands at Dassault Systems into one workbench or one platform that you can start leveraging some of these different brands, right? So the way I think about it, and this is a very simplistic way, is, you know, everybody uses an iPhone, or everybody at least knows how an iPhone works, right? So the iPhone operating system is, you know, kind of similar to the 3D Experience platform. And then depending on what you want to do, you have different apps that you can add to the iPhone, your iOS, right? So that's kind of how the 3D Experience platform works. Now, there are apps for design and engineering and simulation, which is the space that we kind of, or at least I play in most. There's also stuff for marketing and sales, you know, product management. There's a PLM that's kind of built in. There's stuff for governance. There's stuff for manufacturing and production via the Delmia brand. So, but what we're going to focus on is design and engineering and simulation, and that's the venture between kind of the SolidWorks brand and the Simulia brand, right? So, and if you guys have not heard of Simulia, so again, Simulia is the brand responsible for all of the simulation tools that are developed by Dassault Systems. So I'll give you guys a little bit of background. I don't like talking about myself because this is not about me, but I did my undergrad at the University of Pittsburgh, which happens to be where ANSYS is based. So I co-op with ANSYS. And then after I finished my PhD, I actually went to work for ANSYS for a little bit. When I transitioned over to SolidWorks, one of the things that was frustrating for me was there are a lot of problems at SolidWorks, and SolidWorks simulation is a great tool, but there are a lot of problems where it hits its limits. The nice thing now about starting to work with Abacus and the Simulia brand is across different physics, there's very few types of analyses that the Simulia brand is not able to solve, right? From vibroacoustics to durability to optimization, you know, to kind of the bread and butter, right? Structures and fluids, electromagnetics. So for me, like it's just obvious that we were doing our customers a disservice by not working closer with the Abacus brand, especially for someone who's a simulation nerd like me, right? So now with the 3D Experience platform and a lot of the things that are going on with 3D Experience Works and the simulation tools on the 3D Experience platform, it's a really exciting time to be a SolidWorks user because you're going to be able to be exposed to a lot of these different tools all inside the Dassault family, right? All under the Dassault umbrella. So again, a little bit about 3D Experience platform. I know you guys are exhausted of it, but some of the things that I think are important, especially for simulation users, it's integrated with SolidWorks, right? So we realize that SolidWorks is kind of the sun that everything else revolves around, right? So if we can't effectively leverage your SolidWorks geometry, no solution that we provide is going to be useful for you, right? So it's integrated. It's also scalable, right? So whether you're doing very, very basic, simple linear analysis all the way up to explicit dynamics or damage modeling or cohesive zone modeling, there is a solution for you. It's on the cloud, right? So if you want to leverage high performance computing, like right out of the box, you can run for most of the tools, you can run on at least 8 cores. But there are, and that's local or on the cloud, but there are ways that you can scale up and run on 18, 36, all the way up to, I think, 288 cores if you've got really, really complicated electromagnetics or computational fluid dynamics problems. So it's on scale, on cloud and scalable, and it's got that SolidWorks DNA, right? So it does have an assistant panel that kind of guides you through an analysis, right? So we realize a lot of our SolidWorks users are not doing analysis every day. So whatever tools we give them, the learning curve has to be not very painful, right? We're going to talk mostly about Abacus today, right? And the Abacus solver. So just a brief description of what Abacus is. So hopefully you guys have heard of it. Abacus, and again, I came from ANSYS. My job here is never to like talk down about the competition, but Abacus is kind of a best-in-class finite element analysis solver as well as multi-physics solver, right? So it does have capabilities for like smooth particle hydrodynamics, acoustics, piezoelectric, piezoresistive, thermal analysis. Where Abacus really shines is complicated material models as well as ill-conditioned contact problems, right? So the situations where you're not exactly sure what faces are going to be coming into contact with other faces during an analysis, right? So it does a really, really great job of leveraging high performance computing. And obviously it's used across several different industries. I know when I worked at ANSYS, some of the industries that, I've been at SolidWorks now for almost 15 years, or Dassault for almost 15 years, right? The first 12, 13 years, I was focused on SolidWorks simulation. The last few years, it's been on 3D Experience Works and the products from Simulia. But Abacus is kind of really, really well respected in the automotive and transportation industry, aerospace because of the CATIA product, as well as in the biospace, right? So a lot of medical device companies are also really standardized on it. So, all right, now let's transition over and talk really specifically about Resimon and what they wanted to do. So Resimon, again, they realized that they felt like, they were, because their really, really high level analysis was not being done by SolidWorks, they were either using a third-party tool or using a consultant. They really felt like it was disjoint, right? And again, they're on multiple continents, so they felt like it was difficult for them to be able to collaborate across, all those different continents. They had people out in the field that they wanted to be able to collaborate with. So they realized that there was kind of a bottleneck in their design and analysis kind of process or workflow. So they said, look, we have three basic use cases, right? One, we would like all of our designers to be able to do really, really basic, simple linear static analysis, leverage design changes in SolidWorks, and be able to kind of optimize their design. They also had some second level engineering simulation that might be like, more advanced contact, multi-step analysis, fatigue analysis. But these two were things, the top two that were things that they kind of felt like they could do adequately, or at least they could do with SolidWorks simulation. The third was this advanced analysis that they were not doing in-house. They were shipping that out, and they wanted to bring this in-house. Because everybody knows, right? When you consult out and have somebody else do your analysis for you, there's nothing wrong with that approach if it's pretty rare, but you give up control of your design, right? You're shipping it out, you're on the other person's timelines. So most companies, if given the option, would prefer to bring that capability in-house, and that's what they felt too. So they said, look, we're going to give you this Resimon bolter. They actually gave us the full assembly. We want you to focus on the kind of the arm here, the boom arm, or the boom bracket. And we would like you to look at this for the first two levels of analysis. So for the designer focus, they wanted us to look at the knuckle joint, run some basic analysis, do some design iterations, and come up with an optimal design, or at least be able to show how designers could leverage SolidWorks as well as the 3D Experience platform they could make design changes in SolidWorks, have those reflected on the platform. For their engineering, their second level kind of analysis, they wanted to do fatigue. This is a multi-step analysis, and they wanted to look at kind of the whole bracket. So let's start there and take a look at how that would work inside of SolidWorks. So here we are sitting inside of SolidWorks. I don't know if you guys have seen the 3D Experience platform before, but there will be, depending on what tools you have, there'll be, well, now with 3D, with SolidWorks Cloud Services, everybody should have this, right? So there'll be a 3D Experience add-in that basically allows you to save your geometry to the platform, right? Now, this is, I think, a release back, so this looks a little bit differently, but basically the same. All this is doing is saving your geometry up into the cloud, inside your collaborative space, which is basically your folder on the 3D Experience platform. Now, it's saving it up there, but it is still linked to your native SolidWorks geometry, right? So if you make a change in SolidWorks, it's going to flag the geometry on the platform to be like, hey, if you're saving, there's also a way to just save directly to the platform. But if you're still kind of working in the traditional sense, the way most SolidWorks users do, where you are working locally on your desktop, if you save it up to the cloud, up to the platform, it's going to tell you if you've made a change on your desktop, right? It's still linked. It's not a dumb geometry sitting up on the platform. So again, their first analysis was linear static analysis. So again, and we'll talk a little bit about the different roles that are available, but they wanted to run linear structural analysis. So I've saved my model up to the platform, and now I'm saying, look, I want to start the linear structural validation app. Okay, so somebody have a question? No? Okay, so it's now it's just opening the linear structural validation app. And the first thing that it's going to do, again, this is the very basic tool. So it's going to ask you, there are only really 4 analyses that you could do: structural, thermal, I think buckling, and was it frequency. So like I mentioned, there's a really nice assistant panel, kind of like the assistant panel that's you can use with SolidWorks simulation, that walks you through the steps required to run your analysis. So you can see what I've done here is I've only imported half. A lot of times when people run analysis, they'll create a configuration for analysis, right? And in this case, there was a configuration that just had half of the model. So what I'm doing here, again, this is the very basic tool. It doesn't have all of the bells and whistles of the advanced. I'm setting a basic mesh size. And what I'm going to do is, again, this is the first level analysis, right? So I'm going to tell it what parts I want to include. So I'm going to turn off, or basically say, look, this other geometry that I'm turning off or unchecking is not included in the analysis, right? So for this simple analysis, I don't want to include that whole bracket. I just want to look at that real small knuckle section. So you can see I've kind of compressed it down to just those 6 parts. Just like SolidWorks, there's a material library that you can import that comes with the software that's got a really nice list of predefined material properties. Obviously, you can create your own material properties. I'm just going to specify that I want all of this to be ASTM A36, and I will apply that to all of the materials. Again, just linear analysis here, so we're not running any nonlinear in this case. So I've just applied that material here to the whole assembly, or this whole sub-assembly, right? And you can see, as we're walking through here and completing these steps in the assistant panel, we're getting those green check marks telling us, hey, you've completed this step. Now, I just want to point this out. Abacus handles contact, or general contact, a little bit differently than SolidWorks and some of the other players in the field. So Abacus and the platform makes the assumption that everything is a no penetration contact. So when you read in an assembly, if you're running linear analysis, it doesn't know that faces that are touching should be bonded, right? So what there is but you can, with one step, there's basically a contact detection tool where I can come in here and say, look, I want you to look at the whole model, find any faces that are touching, and create a bonded contact pair. So you can see it does that for these 6 faces that are touching. So what I've done is I've said those 6 faces are bonded contacts. And now I'm going to go again, just walking through the assistant. I'm going to specify my restraints. So for this particular model, those flat kind of cylindrical top and bottom faces on those washers, I'm going to say they can't move in the Y direction. So they can't move up and down. And then for those conical faces, I'm going to say they can't move in the X and Z direction, right? So kind of, well, you guys can see the X and Z direction here down at the bottom, right? And now I'm just going to apply my load, right? So I'm going to take those 2 cylindrical faces. I can orient the direction, right? So depending on the orientation of the load, I can rotate that triad. You can see it rotated that triad, that local triad that got created. And I'm saying that I want the load to be 2,000, that bearing load to be 2,000 pounds. And that's it. That's really all I need to do for this particular model. So this linear analysis case. So I can go ahead and simulate that. I have the option to run it locally or on the cloud. So with small models like this, I suggest that you would run it locally. I typically only leverage the cloud if, one, I've got a really, really bad or slow computer that just doesn't have computational resources, which is so rare right now. Everybody's got at least a relatively good computer. But if you want to, you can leverage the cloud. The nice thing about leveraging the cloud is you're utilizing the Simulia cloud, which Simulia is constantly upgrading and building those cloud resources. They're really, really tweaked to running analysis, right? So we all know once we buy a computer, within 6 months, there's something better out there, right? So by utilizing the cloud, you're kind of ensuring that you're using best-in-class resources for running analysis. Now, again, this is just the simple linear analysis case. So this doesn't have all the post-processing or pre-processing capabilities of the tools that we're going to show next. But you can see it's got a very, very nice, simple pull-down display we can walk through. So we can see we're looking at factor of safety here. The minimum factor safety is about 1.29. We could take a look at things like displacement vectors, von Mises stresses, reaction force vectors. So we can see the reaction forces for this case. A plot I like to look at sometimes is the compression tension. So this shows you areas of the model that are in compression, areas that are in tension, principal stress directions. But this is just one simple analysis, right? So it's not like it's this is something they could have very easily done inside a SolidWorks simulation, right? So what did they actually want to do though, right? They wanted to be able to make sure that all of their designers could run the analysis, but they could also go, after running the analysis, they could go back into SolidWorks, make design changes, and ensure that those design changes were reflected on the platform, right? They didn't want to have to reset up the model and do any redundant steps. So you guys can see that area of curvature kind of in the back part of the knuckle had a factor of safety that was about 6. So again, we wanted to highlight how they could make changes very, very quickly. So you can see we're back in SolidWorks now. What we're going to do is we're going to change that radius of curvature for the fillet from 30 down to 10 millimeters. We're also going to change the thickness from 30. I think we change it down maybe to 20. And with the push of a button, I can re-upload the model. I could also add revisioning, right? So one of the things that's natively built into the platform is revision controls, right? So Innovia, which is the PLM product developed by Dassault Systems, is kind of working in the background, right? So you could do a major and minor revisions if you wanted to. In this case, I think we're going to make the assumption that we're still working with the A.1 revision. We're not actually creating a new revision, but if you wanted to, you certainly could. And we're going to update. We can also add comments, right? So, again, I'm an engineer, so I understand we kind of hate documenting our work sometimes, or it's something that we think we'll do later and we never do. Very, very easy to add comments so that, somebody else who's looking at your work, whether it's your boss or, maybe the designer, can see exactly what you're doing, and, the product manager. So we can make that update. Once we make the update, with a push of a button, we can refresh this. And just keep your eyes focused up here, like kind of where we made those design changes. You can see it automatically updates. And again, with the push of a button, it's telling us the results are out of date. We can go ahead and rerun it and evaluate the changes. We can even keep the old, the initial analysis so that we can compare them in the future. So we showed that to them. They were very happy. Again, this is something that they were kind of doing inside of SolidWorks already, though, right? So this at least gave them a little bit of comfort that they were at least getting the same capabilities that they had inside of SolidWorks. So I see a couple comments in the chat. I'm gonna just take a look here. Okay, no questions. All right, so let's. Oh yeah, great. Yep. Absolutely. So there's an option to keep previous results. So when you run the analysis, there's an option that allows you to keep the previous run. And then by doing that, there's actually some compare tools that are available natively in the platform. And I believe we're going to show that in a couple slides. So yeah, yeah, but there definitely is, even if we don't show it, there definitely is. So all right. So yep, no problem. Let me keep going here. All right, so they were happy with that. Now they said, all right, let's talk a little bit about some engineer level simulations, right? A little bit more advanced. And this was very important to them because they were seeing a lot of field failures that they thought were associated with fatigue. So here's the model inside the platform, right? Now we uploaded this model initially, right? We had this whole model uploaded. For the designer level simulation, we just focused in here on the knuckle. Now I'm utilizing a little analysis trick here. There was a configuration created that was only half of it. So I'm utilizing symmetry. Now I know a lot of people don't like to utilize symmetry because they have to explain it to their boss, but and a lot of times bosses are like, why am I only looking at half the model? But symmetry is there's actually a way to show the results, the full results, if you do model symmetry, right? And it doesn't have to be half symmetry. It can be quarter symmetry, 1/8 symmetry, 1/16 symmetry. So if you've got a boss who doesn't understand symmetry, there's certainly a way to show the results. So let's talk a little bit about this particular analysis. So this is the full bracket. What we're showing here is the force versus time. This is actually a two-step analysis, right? So we're not running this in it's not a transient analysis, but when you run nonlinear analysis, time kind of is it's pseudo time, right? So typically what people do when they run nonlinear analysis is if you apply, let's say you're applying one load or one load case, what a time of one typically means is that at time one you've applied 100% of the load. So time kind of acts as a marker to scale up the load application. And that's typically how it works. There are certainly different ways. Sometimes people will, like, let's say you're applying 100-pound load. Sometimes people will say, well, then I want that to run to a time of 100 seconds, pseudo seconds. That way, each second kind of reflects 1 Newton of load, right? It's just the time represents scaling of your load. And then if you have multiple load cases, which is what we do here, so time one is the end of the first load, which I think is the bolt kind of pretension. And then time 2 is the end of the second load, which is where you're locking down the bolts and applying the external load. So lots of different ways to run analysis, but that's how we're running it in this case. And utilizing each load step as being 1 second or in pseudo time is typically what people do. But again, if you ask a dozen engineers, you might get half a dozen different answers about how they handle nonlinear analysis. So another thing I want to point out here is so we're utilizing different mesh. It's kind of hard to see here, but for the washers down here, we're actually utilizing a brick mesh, which is something you could not do in SolidWorks. We're also utilizing a screw or a bolt, a virtual bolt, and virtual pins here in the analysis. So again, lots of different bells and whistles that are available that to make this very, very easy for designers to take advantage of. So you can see for this section, we're actually using a brick mesh, something that we could not do in SolidWorks, right? You're forced to using a temp mesh. The reason this is transparent here is because this is actually a virtual bolt or pin. In this case, I think this is the bolt. So you've got the ability to do virtual bolts just like you do inside of SolidWorks. The other thing that's available is there are different element formulations. So if you're like running hyperelastic materials, there are certain element formulations that are better for hyperelastic materials. So again, we're really leveraging the power of the Abacus solver here, with a much more modern user interface, right? So you can see different mesh sizes for each of these. I'm utilizing general contact. So I pointed this out before. The nice thing about general contact, I don't have to specify contact pairs for my no penetration contact. I can just turn on general contact, and the assumption is any faces, whether they're touching or not touching, are considered no penetration contact unless I override it, right? So this is kind of the default, unless I say, hey, these faces are bonded or specify some other contact pair. So I'm utilizing general contact. I don't need to specify any contact pairs. I'm specifying a contact property here, which controls the friction. So this contact property just controls the friction coefficient for these faces. Now, if you had different materials with different friction coefficients that were touching each other, obviously you could have multiple contact properties and then just specify the surface contacts that have different contacts. So the general contact is great for just kind of a default setting for all the faces that don't have different properties for curve. So really, really easy to set this up, take advantage of symmetry. This is a multiple procedure analysis. So you can see it's a 2-step analysis. The first step, we're applying that bolt preload. And then the second step, we're just restraining the bolt, keeping that preload applied. And, you know, there are different boundary conditions here. There are some hinges. So we're going to run this analysis. And again, you can run on the cloud, run it locally. And then we're going to, after we run the analysis, I don't know if anybody's done fatigue analysis before, but the way a fatigue analysis is typically done is you run a structural analysis first, and then the results of that structural analysis kind of feed into your fatigue analysis to give the stress limits, kind of the S and the SN curve that this model is going to be subject to cyclic loading on, right? So this is the results of the structural analysis. So let's kind of walk through this a little bit. Force. So you can see this is showing us the von Mises stress. Again, when we run fatigue analysis, what we do is we typically point to, another nice thing is when you run fatigue, you can actually specify a global surface finish, right? So again, if you're running fatigue, you know, surface finish is something that's very important. So you could specify the default surface condition for all of the faces. And then if you wanted to override it, at any specific locations, you can do that. Now, again, when you run a fatigue analysis, typically what you do is you point to a parent structural analysis. So what I'm going to do is I'm going to say, look, I want to add a frame that points to the last increment of that, the second step of the structural analysis, the last increment of that bearing load. And you can specify it goes from -1 to, so this is basically saying that the loading goes from 0 to whatever the maximum positive value of stress is. So that's 0 to 1. You could also do negative maximum value to positive maximum value. It just basically defines the stress range that's being looked at in your fatigue analysis. And then fatigue analysis typically runs very, very quick. And again, we do have a predefined library of material properties for fatigue. So we could go ahead and run the durability analysis. And what the result that we typically are interested in when we run durability analysis is the log of life. So what log of life gives us is whatever the minimum value is. This means that the model can withstand 10 to the power of 4.59 cycles at wherever the minimum is. So if we kind of zoom in here, we can see the minimum actually is here at the washer, I believe. So, you know, we can determine based on however long we want this thing to be able to last, right? And how many cycles, basically, how many cycles is this thing going to see per year or per use? If 10 to the power of 4.59 is adequate for this particular design. All right, so yeah, nothing. That was just kind of comparing the initial and final designs for the simple analysis as well as the final analysis. And this is actually a typo. It should be to the 4.59. Okay, so now let's look at, so those were, again, things that they felt like they could do with SolidWorks simulation. Although this engineering level simulation, they really felt like they were not doing a good job. And they wanted to utilize a tool, kind of just a more advanced or a more well-respected tool for those types of analyses, which obviously Abacus is a world-renowned and world-respected tool. So now they wanted to run the advanced analysis. So here's a little look at what the falling object protection looks like. So for wherever, for this particular industry specifications, they had 227 kilograms that they wanted to drop 5.5 meters. And they were interested in that, the safety of the person in this place. Now, I don't know about you guys, but I would not want to be sitting in that place as they're running these tests. So let's just take a look at this. So we can see what that looks like, right? And the intent here after they run the analysis is they want to look at the amount of deflection that they've gotten that top canopy, right? So this is a simulation that they were doing one of three things, either building prototypes and physically testing it, which you guys can see. It's a long process. You certainly don't want to be doing that for every design, right? You only want to be doing it for designs that you're pretty sure are going to meet your requirement. Or they were trying to utilize that third-party tool, which you know, they didn't have people that they felt like were comfortable, or they were consulting it out. So we were able to show them how they could solve this using the explicit solver inside of the 3D Experience platform. And we were able to basically mimic what they were seeing in the field, right? To a very, very high percentage of accuracy, right? Within a few percent. And again, I'm not one of these analysts who was like, oh, you can eliminate prototyping and physical testing, right? But I do think if instead of doing 10 prototypes a year, you can do 2 or 3 prototypes, you're saving a lot of money and a lot of time, right? So this is a real benefit for them. So they also were interested in doing rollover protection, both for top loading and side loading, right? So that's what this looks like. So again, there are industry standards for that, both the falling object protection as well as that top loading that they were utilizing. for these analyses, right? I'm going to skip this here in the interest of time, so let's go ahead and so there are four on the structural side, and I'm going to focus on structural. If you guys want to do another session where we talk about EMAG or fluid dynamics, I can do it, or I can have one of my colleagues do it. If it's EMAG, it'll definitely be a colleague. But the structural side, we kind of followed that same good, better, best methodology that we've used with SolidWorks with like standard professional premium offerings. So if you're just interested in doing really, really simple kind of first pass analysis, you've got structural designer, all the way up to durability and mechanics engineer, which is kind of the top level package that can do explicit dynamics, damage modeling, material calibration. So, you know, I don't like talking about product names because I don't think it matters to our users. You know, if you see something here that you're interested in, talk to your reseller, feel free to reach out to me. And depending on the analysis that you're trying to do, we can figure out which package makes the most sense. You don't care about what the names of our products are, right? Who cares as long as it solves the problem that you're interested in. So that's where I'll wrap up. And